In this video, I would like to show you how to make the famous 2048 game using C++. I will assume that you have already at least seen C++, so I will not explain everything. However, I will only use very basic features of C++ so you can follow along even if you just started learning. The UI part will be handled by the CPP graphics library. The library is cross-platform and you can follow the tutorial on either Windows, macOS or Linux. There is a separate video about how to set everything up, so make sure you watch it first and get ready. The link is in the description. The game itself is simple. There is a 4x4 grid of cells, each either empty or containing a number. The game is controlled using arrows. When an arrow is pressed, all numbers move in the respective direction as far as they can. When two equal numbers collide, they are merged into one number with double the value. A new number is then added randomly. The goal is to make the number 2048. What I am now showing you is the application that we are going to make. The only difference is that I will not fiddle with the UI so much, so at the end of this video it will look like this. The game was originally written by Gabriel Cerulli as a weekend project, and it became famous shortly after being released. There are several sites where you can play it online, and I suggest that you do it to get the idea. There is a link in the description. What I am going to show you is my own implementation. I have not studied the source code of the original. It may differ slightly in how it behaves. Before we start to actually write some code, let's first think about the problem and try to break it down into smaller pieces. This will help us make the big decisions about how to store our data and how to structure our code. The overall flow of the game will be as follows. We create an empty grid, place a new number randomly, draw the grid on screen, wait for a key press from the user, do the move, check if there is some space left. If there is not, we would quit, and then we can go back to number 2 and repeat. Most of the steps seem to be quite easy. The most sophisticated one is number 5, where the numbers are moved and the collisions processed. However, all the rows or columns can be clearly processed separately, and the logic will be the same regardless of the direction, so even that step should be possible to reduce to squashing a single row of 4 cells. All the data that we need to keep is the 2D array of integers, which we will read and possibly modify during the individual steps. Empty cells can be represented by zeros. The array could also be a 1D array of 16 numbers, but given that the logic of the game will work with the columns and not just the individual numbers, the 2D array might be a better option. Yet another approach would be to only store the non-empty tiles and their positions, but that doesn't feel right in this case. Apart from the logic of the game itself, there will be some UI interaction in steps 3 and 4. We should do our best to separate concerns and not mix the game logic and the UI code. We will see how easy that will be, but we should at least keep this in mind. Now that we have roughly planned what we are about to do, we can start. I have already created a blank CPP graphics project. See the video linked in the description if you haven't already. We will obviously need some way to visualize our progress, so let's first create our window. I will include the CPP graphics header, implement the main function, and call cgCreateWindow, passing the name and dimensions of the window. Because I don't want the window to close immediately, I will also call another function cg wait until closed. And of course a return 0 is mandatory because the main function has to return something. We can now try to build and run our application. As you can see, the window works, but it doesn't do anything yet. Let's now create the 2D array our numbers will live in. We will use std array for this, so I will add the respective header and declare the array itself. This is how the declaration looks. Because it's a 2D array, it is an array of 4 arrays of 4 integers. You may be tempted to use a C-style array, which would be declared like this. Don't do this. The problem with C-style array is that they are quite difficult to pass in and out of functions, which is much easier with a std array. The array itself doesn't know whether the internal arrays are rows or columns. That is up to us. Let us now agree that we will use the horizontal coordinate as the first index and the vertical as the second. Also remember that the index of the first element is 0. We can now write a function to draw the grid. We can call it draw, and we will call it just after we created our grid. And we will pass our grid as a parameter. The implementation of the function will be as follows. Now this will work, but it passes the grid by copy. When the function is called, a second grid is created and the values from the original one are copied into it. The function can only access the copy, and the copy is destroyed when that function returns. Not that it would have an impact in this case, but it makes more sense to pass by reference, by appending an ampersand after the type. This way, the function works with exactly the same grid as the calling code. And one more thing, when passing by reference, it is good practice to use const reference whenever you can. Our function will only read, so we will prevent it from writing to the grid using this reference. This improves the readability of the code a lot, and it also protects you from accidentally modifying something that you didn't intend to. Notice that writing the type in full is not exactly nice, and we will be doing this a lot. To save us some typing and further improve the readability of the code, we can declare an alias for the type. We can do it at file scope by the using keyword. This basically says that when you type grid, you mean the array of arrays. This allows us to rewrite the code as follows. Now the actual implementation of the function. The first thing the function should do is to clear the screen, because we will call it repeatedly. Now for the actual drawing, it helps to start with a pen and paper. My window is 800 by 800 pixels, so if I decide to have 100 as a margin, I am left with a 600 by 600 square for the cells. This means that each cell will be 150 by 150, and the center of top left cell will be at 175, 175. At this point, we will only draw the number to the center of the cell. We will iterate over the rows and columns like this. And we will draw each of the numbers to its respective place. There is a nice function in CPP graphics to do this, CG centered. We can have a look at this declaration. This one. As we can see, it accepts std string as the first parameter, so we must first convert our integer to std string. There are several slightly different functions to do this in C++. I will use probably the simplest one, and that's std to string, and I will pass the value. The text-centered function also needs the position of the text. We start at 175, 175, x counts columns, y counts rows. And we also need to specify height of the text, let's say 50. Good. Now let's try that. All is well, except that the numbers are rubbish. This is because the array is not initialized, so the initial values are whatever was in the memory when it was allocated. We should initialize it ourselves. It makes sense to write another function that will create a grade, fill it with zeros, and return it by values, which would be done like this. Then we can modify the main function and we can try again. As you can see, the grid is now initialized with zeros. To make it nicer to look at, I will also draw a rectangle for each of the cells. I will first set color to black, fill color to orange, and background color to brown. And then as I iterate over the grid, I will add CG rectangle, and the coordinates of the rectangle can be easily seen in the drawing. Good. Let's try again. I will also add a condition so that we do not draw the number if it is 0, because as we agreed before, 0 represents an empty cell. So if the number is 0, I will draw the rectangle, but not the text. And we can try it again. There are only zeros in the grid, so nothing is shown. Let me now remind you about the steps that the game will be made of. So far, we have addressed numbers 1 and 3. We now need a function that will add the new number to a random position. For now, we would like to call it just after the empty grid is created. So the function signature will look like this. It will be a void function named new number, accepting a reference to our grid as a parameter. The reference is not const because we are intending to modify the values. Now, there are several ways to get a random number in C++. But in this case, we will just use a random int function provided by the CPP graphics library. A naive approach would be like this. it simply places the number in a random cell. The reason this is naive is that the target cell may not be empty. We don't want to overwrite non-zero cells. There are several ways to address this. The simplest one is to keep generating the random pairs until a non-zero cell is found. This would be implemented like this. I will store the random numbers in two variables. Then I will check that the position is empty. And if so, I will insert the new value and return. These commands will repeat in a loop. There are two downsides. The first is that if the grid is almost full, it will generate multiple pairs before an empty cell is hit, but that's not that much of a problem when the grid is this small. The other downside is that if the grid is completely full, the loop will be infinite. We must make sure to never call this function in this case. The game is already lost when that happens anyway. Now that the function is ready, we can check the result. And I will try to run the application multiple times. You can see that the position of the number is always different. This is where things start to get interesting. We are about to process the input from the user and start reacting to it. We will first add a loop into the main function so we can repeat the whole cycle. The loop shall break when the window is closed, which we can check using the CG isWindowOpen function. The CPP graphics library provides several functions that wait for input. In this case, we will use the CG wait until key pressed function. This one. The function waits until the user presses the key and then returns an integer identifying which key it was. There is a list of constants in CPP graphics HPP that we can compare the returned value to. For now, our goal will be to add a new random number after each key's press. We have all the functions ready, so it is quite simple to do. As you can see, it is working nicely. We can now interact with our application. Each key press adds a new number, never overwriting anything. We can consider step 4 as implemented. The only problem is at the end, when there are no empty cells left. In that case, our new number function ends up in the infinite loop that we mentioned before. We should now do something about it. It is quite straightforward. We shall make a function to return a boolean value telling us whether there is an empty cell or not. The signature will look like this. Bool is the return type. Function name will be isFull. And we pass a const reference to our grid. The implementation is also straightforward. We must iterate over all the cells and check if they are 0. if there is one. We are done and we can return. If we get to the end of the function, it's clear that there was no zero in the grid, and in that case, the grid is full and we can return true. Now we have to call this function somewhere. We will check the grid at the end of our loop, and if it is full, we'll break the loop. I will also remove the wait until closed call, so when we get to the full grid, our application will close. We can now try it. As you can see, the application terminated before jumping into the infinite loop. One more step is done. As you can see, I left the most important step until the end. We now need to implement moving the numbers and merging them together. This looks quite challenging, so let's first simplify the problem and only implement moving downwards. Once we have that, we can think about a way to generalize it for the other three directions. As usual, we will create a function that will do this. We will call it immediately after the user pressed the key. It will take a non-const reference to our grid and modify it in place. As we discussed at the beginning, we need to do the same thing for all 4 columns. And because the columns are stored as arrays of 4 ints, we may simply iterate over the 4 arrays and treat them equally. The iteration looks like this. The squash column will be another function that only works on a single array of 4 ints. This function will be the actual core of our game. It will accept a non-const reference to an std array of 4 ints, and because we are moving the numbers downwards, the function shall move the elements to the end. Just to make sure that we did everything correctly so far, let's plug in a simple implementation that will do something silly, such as multiply the last number by 2. Now we can test it. As you can see, everything works the way we want it. Our goal now is to replace the simple implementation of squash column with something meaningful. First, we need to agree on the behavior that we want. For example, if we have a situation like this, should we merge the numbers at the front or at the back? The result will be different in both cases. I will implement the variation that first merges the numbers at the back. Or take a situation like this. We will merge the 8s together, but should we also merge the result with the incoming 16 and 32 in the same turn? We must decide which of these options will make the game more fun to play. I will implement the variation that does not merge numbers repeatedly. I suggest that you now pause the video for a while and try to think about how to approach it. There are multiple ways to do that. The one that I found easiest is to iterate from the back and for each element find the next non-zero element to the left. Then I will either add that number to the one in current position or do nothing, depending on the numbers in question. It will be quite obvious from the code. Let's start with the iteration. Now, for every position, I need to find the next non-zero number, which I can easily do in a loop like this. I also have to handle the case when there is no such number, in which case I am done and I can break the outer loop. Now there are several cases to handle. If the current number is equal to the next non-zero number to its left, I can multiply the current number by 2 and zero the next one. Current number can also be 0, in which case I will simply swap the two numbers using the handy std_swap function from the standard library. I am nearly done now. There is just one thing missing. You may be wondering why I did not just add the next number to the current one and replaced it with 0, which would have covered both cases. The reason is that there is a slight difference between the two. When a number is moved, there is still a possibility that the next number in the line will be merged to it, which current algorithm would not do. Therefore, if I only performed a plain move, that number should be processed again in the next iteration. The easiest way to do this is to increment the loop counter. It will be decremented again by the for loop, meaning that the next iteration will again work with this number. The following animation demonstrates the algorithm for one specific case. We can now check that everything works as we expect. It seems fine. Note that the inner loop, which looks for the next non-zero number to the left of the current one, might be written slightly cleaner by using the fact that the non-zero number is always to the left of the one we found last time. You can try to improve this as an exercise. The last thing that remains is handling the other directions. Probably the easiest way to do this is to transform the grid in such a way that we can use our downward moving function and then transform the result back. For example, if we wanted to move the numbers upwards, we would flip the grid along the horizontal axis and back. If we wanted to move to the right, we would flip the grid along its diagonal. I can easily extend our squash downwards function to do this. First of all, I will rename the function to squash, so the name is not misleading. Then, the function must know in which direction it should move the numbers, so I will add a parameter and pass the integer I got from the CG wait until key pressed call. It is just an integer, so I pass it by value. Now, if the up arrow is pressed, I want to do about this. First, I flip the grid vertically. Then there is the move downwards. Then I flip the grid back. We must implement the flipping function, but that is quite easy. We will again do it column by column, so the first part is iterating over all the columns, like we already did before. And in each column, we want to swap elements 0 and 3 and 1 and 2. I will again use the std_swap function from the standard library. We can now check whether it works. It seems to be fine. The only thing missing are the right and left moves. Flipping the grid diagonally will map both horizontal moves to vertical, and we can now do them both. I will add the logic to the squash function without commenting on it, so you can think about it yourself. All we need now is the flip diagonally function. I will just manually swap the respective elements. It can be done much more nicely by using some loops, which I will leave to you. As you can see, our game is now functional. There are several things that I omitted so the video is not too long and that it stays on topic. Let me just quickly tell you about some of them. Let's first look at some of the game related ones. We did not add the detection of the 2048 number, so the game will never tell you that you won. This is very easy to add. The logic doesn't check that the user pressed one of the arrows. If you press any other key, it moves the numbers downward. This is also easy to fix and you can try that. Another problem occurs when you press one of the arrows, but the numbers can't actually move that way. In that case, nothing happens and a new number is added. This is different from the original because it allows you to skip your move. One way to fix this is to make a copy of the grid before the move and compare it to the grid after. Another way would be to extend the squash function to return a boolean saying whether something happened. Again, something that you can try. The user interface is quite ugly. We might change the background of the tiles depending on the value, choose the window background nicely and so on. This is fun to play with and it is not complicated, so I encourage you to try. This is what I got after some experiments. Of course, there are many other features the game might have, such as keeping score, saving and loading the position from a file, undo, and so on. There are also some things in the code that are worth mentioning. The way we are generating the random tiles is not exactly nice, and some people may claim that it is wasteful and inefficient. We might improve this by first collecting the empty cells and randomly selecting one of them, but in our simple case when the grid is this small, it would not make any measurable difference except for maybe looking more professional. Another thing to mention is the way I pass the direction to the squash function. Like I mentioned at the beginning, this mixes the game code and the UI code more than is necessary. In an ideal world, the squash function would not depend on our UI library. We might declare our own constants that would specify the direction and map the key to it before the squash function is invoked. The same applies to using the random number from the CPP graphics library. The new tile function should not use the CPP graphics library at all, and instead it should use the random number generator from the standard library. It does not make a difference in this simple project, but in general, it is a good idea to keep the application logic and the UI as separate as possible. It makes debugging and working with the code easier, and it also makes it possible to port the application to a different UI library and make similar changes. So that's about it. The link to the complete source code that we created is in the description. I hope that you liked the video, and I will appreciate if you will let me know what you think about it in a comment below. Thanks for watching.